In this tutorial, we'll use the library CQCalendar to build an in-game time system from scratch in Python Tkinter. So by the end, you'll have the time displayed up here, and as you can see, it's incrementing every second. Then you have the date displayed underneath it, which will also update with the time. And then you have the current moon phase, which will also update. And then down here, we have the different controls for the time. So right now, the time is playing, so I'm going to hit pause and pause it. As you can see, it stopped. I'm gonna hit play again to start it again. And these buttons right here control how fast time goes. So this one is 1 minute, and then this one is 5. So it's 25, 30, 35. This one is 15, and this one is 60. All right, so that's what we're going to be creating in this tutorial. Before getting started, we have to install the CQCalendar library. All right, so open your command prompt and type in pip install CQCalendar. Hit enter and wait for it to install. And of course, I already have it installed on my computer, so we're ready to go. So the following starter code creates a full screen Tkinter window for our project. So if you want, you can just pause the screen and type this in real quick. And when you run the code, you should have an empty window like this. All right, so we first have to import CQCalendar into the file. So we'll just do from CQCalendar import CQCalendar. And so the next step is to initialize a CQCalendar object inside of the root class. So just go down here, self.calendar is equal to CQCalendar. This is fine if you want the calendar to start at the default time and date, but if you want to set it to a specific time and date, you can pass in some different parameters. If you want to set the calendar to a specific time, you can pass in an hour parameter, which has to be an integer. Or you can pass in a minute parameter, which also has to be an integer. And finally, you can pass in an is_PM parameter, which is a Boolean. Okay, so for this example, I'll just set this to 9 a.m. So we'll set hour to 9, we'll set minute to 0, and we'll set Boolean to, we'll set is_PM to false. Now to set the calendar to a specific date, you'll pass in month, which has to be an integer. You can pass in day, which also has to be an integer. And then you can pass in the year, which has to be an integer also. Okay? And so what I'm going to do is I'm just going to do January 1st, year 1. So I'll set month equal to 1. I'll set day equal to 1 and year equal to 1. Okay, to set the calendar to a specific weekday, you'll pass in the weekday parameter, which has to be an integer, okay? And so the weekdays are 0 indexed, which means that Monday is 0, Tuesday is 1, Wednesday is 2, Thursday is 3, Friday is 4, Saturday is 5, and Sunday is 6. So I'm just going to set this to Monday or 0. To set the moon phase, you'll pass in the moon_phase parameter, which is a string. So we'll do moon_phase, and that's going to be a string, okay? And so this uses the standard moon phases. So if you don't know them, they're new moon, waxing crescent, first quarter, waxing gibbous, full moon, waning gibbous, last quarter, and waning crescent. So I'm just going to set this to new moon. Okay. Okay, so now that the calendar is set, we can display the time, date, and moon phase as labels inside of the app. So starting with time, inside of the root class, we're going to create a label that displays the time and a string var that we'll use to update the label later on. So down here, we'll just do self.time_var is equal to string var. Then we'll do self.time_label is equal to label. We'll pass in self or the root as the parent. Then we'll set the text variable equal to our time_var. Okay, now we'll just display it. So we'll do self.time_label.pack. Okay. Just like with time, we'll create a label in string var for the date. All right, so we do self.date_var is equal to string var. Self.date_label is equal to label pass in self or the root as a parent. We'll set text variable is equal to self.date_var. Then we'll display it with self.date_label.pack. Okay. Yet again, we'll repeat the same process for the moon phase. So we'll do self.moon_var is equal to a string var. Self.moon_label is equal to label, pass in self or the root as the parent. We'll set text variable equal to self.moon_var. Then we'll display it with self.moon_label.pack. Okay. Next, we'll create an update screen method that we'll use to update the string vars for the time, date, and moon. All right, so we'll just go down here and do define update_screen self. Okay. So the CQCalendar object has a time string method that'll return the current in-game time as a string. So we'll just use that to update the time var. Okay, so we'll do self.time_var.set. We'll do F for formatting. We'll do time. Curly brackets self.calendar.time_string, and we'll have to make sure we call that. Okay. Okay, so there's also a date_string method which returns the current in-game date as a string. So we'll just do date_var.set format date curly bracket self.calendar.date_string. Okay. All right, so finally, the moon_phase_name method returns the current in-game moon phase. So we'll just do self.moon_var.set format moon curly brackets self.moon_phase_name. Okay. So the last thing we have to do is call update_screen at the bottom of the root's init. So just down here, do self.update_screen. All right. If you run the code, you should see a time, a date, and moon phase label, and they should be set to whatever you specified inside of your CQCalendar object. Okay, so now that we can see the time, we want to add a button that allows us to start and stop it. But first, we have to add a Boolean to the root class that we can switch on and off to control time. So right up here above the update screen, we'll just do self.running is equal to false. Okay. Next, we need to determine how often we want the time to update. So we'll set it to 1000 milliseconds or 1 second. So we'll do self.tick_delay_milliseconds, and we'll set it to 1000. Okay. Finally, we define how many ticks should pass each time the update happens. So we'll do self.ticks per update is equal to 1. Now we're going to create the frame that all of the buttons will be placed inside of. So we'll do self.control_frame is equal to frame. We'll make the root the parent. Then we'll do self.control_frame.pack to display it. Then we're going to create the play/pause button. We'll have it say play initially, and we'll add a command that is going to toggle the button between the play and pause state. So we'll just do self.play_pause button, and we'll make the control frame its parent. We'll set its starting text to play, and then we'll set its command equal to a method called self.toggle_play_pause, which we'll create in a little bit. Then we've got to display the button, so play pause_button.pack, and we're going to use the side option and set that equal to left. Or you can do a string also left. Okay, so next we'll actually create the method that toggles between the play and pause state. So we'll go down here and do define toggle underscore play underscore pause self. Okay. So inside the method, we'll invert the self.running attribute. So if it's true, it'll become false, and if it's false, it'll become true. So the self.running is equal to not self.running. If time is running, we'll set the play/pause button text to pause, and then we'll start the game loop, which we'll create later. If self.running, so if that is true, we'll do self.play underscore pause underscore button dot config, and then we'll set the text equal to pause. Okay. Then we'll run a new method called game underscore loop, which we will create in a little bit. If time is not running, we'll set the play/pause button text equal to play. So we'll just do else self.play underscore pause underscore button dot config text is equal to play. Okay. Now we have to create the game loop method that we referenced earlier. So we'll do define game underscore loop self. So if time is not running, we do not want game underscore loop to run. So we'll just exit the function using return. So if not self.running, or if running is equal to false, return or exit the function. If time is running, we want to increment or have time move forward by calling the CQCalendar's update method. We want the calendar to update by however many ticks we set the ticks per update variable to. All right, so we'll do self.calendar.update, and then we have to pass in a ticks parameter, and we'll set that equal to self.ticks underscore per underscore update. All right, so we want the screen to display the updated time, so we'll call update underscore screen. All right, so we'll do self.update underscore screen. So if time is still running after the screen has been updated, we want to wait 1000 milliseconds or 1 second and then run game loop again. So we'll just do self.after. We'll pass in self.tick underscore delay underscore milliseconds, and then we'll run self.game underscore loop again. All right, so if you run the code, you should be able to start time. And as you can see, it's being updated here. And then now we should be able to click it again and it pauses time. So now that we can start and stop time, let's add buttons that allow us to control time speed. First, we're going to create a list of speeds that we want to create buttons for. Each speed is going to be represented with a tuple, where the first value is the text that we're going to use for the speed button, and the second value is how many ticks the calendar will be updated by. So back up here, we'll do this underneath our play pause button. We'll do self, we'll do speeds, it's equal to a list. And then inside, we'll create a tuple for each speed. So first one is going to be 1x time, and that's going to be 1. The second one is going to be 5x time, and 5. Third one is 15x time, 15. And the final one is going to be 60 x time and 60. Okay. So next we're going to use a for loop to create and display the speed buttons. So we'll do for each label in ticks in speeds, we'll create the button and we'll place it inside of our control frame, and then we'll set the text equal to the label. Then we'll display the button, so button.pack, we'll place the side at left or set side equal to left, and then we'll just add pad x just to make it look a little bit better. So pad x is equal to 5. All right, so we'll also add a command to the buttons that take the number of ticks as a parameter, and then we'll create the command function afterwards. Okay, so down here we'll do command is equal to lambda. We'll set t equal to ticks. And then we'll call a method called self.set_speed. And then we'll pass in t, or the number of ticks. Okay, so now we have to create this set speed method here. So we'll just go down here, do define set_speed. We'll pass in self and the number of ticks. And then we'll set the ticks per update variable to whatever the ticks parameter is. So we'll do self.ticks_per_update and set that equal to ticks. Okay, so now if you run the code, you should be able to start time, you should be able to pause it, and you should be able to click each of these buttons. We'll start with 5, and as you can see, it's now incrementing by 5 minutes. We'll click 1 again, now it's back to 1, 15. Now time is going by 15 times speed, and then we'll do 60 for an hour here. Okay. All right, so now you've built a functional in-game time system using CQCalendar, and this is really a foundation you can expand into things like NPC schedules, shop hours, quests, seasons, and etc., right? So that's pretty much it for this video, and thank you for watching.